All right, we're making some real progress here. There's almost an infinite ways that you can view and select data with Pandas data frame. We're only really scratching the surface here, but once you learn these foundation steps, you can really combine them in kind of any different way you can imagine and really transform and view your data in a different light. So let's keep going. We're still viewing and selecting data at the moment. So the next one I want to show you is PD crosstab. This is a great way to compare two columns if you want to see them like a little innovative, is that the right word? I'm not sure, doesn't really matter, but you'll see. A little comparative way, maybe that's a bit better word. So crosstab is basically going to say, hey, Pandas, grab the make column. Let's refresh our memory of what our data frame looks like. We have make, which is car makes, doors, which is here. So this is going to cross over the make column with the door column. And so crosstab is you call pandas.crosstab and you pass it one column and then another column. So we got here, these are doors, the amount of doors, 3, 4, and 5. So we've got 3, 4, 5. And these are the different makes here. We got 4 different makes, Toyota, Honda, BMW, and Nissan. Beautiful. And so what this is doing is it's kind of aggregating these two columns together. So let's explore this. BMW, there's one car with 5 doors. Honda, there's 3 cars with 4 doors. Toyota's the only car brand that has 3 doors. I'm not quite sure what that car would look like, but who knows? This is kind of data you'll come across. Okay, now crosstab is great for comparing 2 columns, but what if you wanted to compare more columns in the context of another? This is where a group by comes in. So let's put a little comment here, group by. So we're going to go car sales. I was going to say PD. I'm used to saying PD. Group by, and we want the make column. Dot mean. Now, what do you think before we even run this code? Now, I'm going against my only rule here of always run the code first. What do you think this will do if we looked at this? So we've got car sales, which is our data frame. That's up here. We've got this little function here called group by. We know it's a function because it's followed by brackets. And then within the group by, we've got the make column. We've got mean. How to think about it? Doesn't matter. You should write the code out first and press shift and enter and see what happens. So what this is going to do is it's going to group the data frame on the make column, similar to what our crosstab did, but this time we have more columns here. So it's given us the mean values of the odometer of all the different types of makes, as well as the doors. So BMW, the mean odometer rating is 11,179, and the mean amount of doors is 5. And that makes sense because there's only one BMW car. But again, this group by, you could group by almost any column you could imagine, and then call some operation on it as you go. And you can imagine if you had more columns here and you wanted to combine them in some way and view them, you can use this group by function to make sure you only group it by a certain type. Maybe you want only white Toyotas. Maybe that's a little exercise. See how you could group it by only looking at, is there 2 white Toyotas? Yeah, 2 white Toyotas, and then seeing what happens from there. But I just want to show you group by. It's kind of like crosstab, but for focusing on more than one column at a time. So what's next? All right, well maybe we have a look at some visualizations. Yeah, that's a great idea. So we go car sales, odometer. Let's see if we can do a little plot here. I'm going to call .plot. What do you think this will do? Run that. Beautiful. We get a plot of the different odometer values. So this is what the beautiful thing about Pandas is, how beautiful and how quickly you can get an analysis going. And you might look at a table like this and not really be sure what's going on, especially have lots of rows. But getting a visualization out is a great way to quickly understand what's happening. And we'll have a section coming up on how to make these visualizations a bit more interactive and a bit more prettier with labels and different information here. But what you might find is that if this plot doesn't show up, you might need to run these 2 lines of code. And this is matplotlib inline, because you see here, this is generated. This plot is actually, Remember how we created an environment and it installed a whole bunch of tools for us? Conda did that for us. When we created our environment, it installed matplotlib because some of the functionality, like the plot function in Pandas, depends on matplotlib. So behind the scenes, Conda has actually set this up for us. And when we imported Pandas right up the top here, we won't go right back up the top because that'll take a little while. But when we typed in import Pandas as PD, it might have done some work behind the scenes for us to organize this plot. But if it hasn't, you can type in these 2 lines of code, import matplotlib.pyplot as PLT. And this one here, this percentage sign at the front is a little magic function. Jupyter notebooks have different magic functions which do a specific kind of thing. All this is saying is plot our matplotlib plots inside the notebook so we can see them. So if your plots don't show up, make sure you've run these 2 lines of code. So you can type them and put them at the top of your notebook potentially if your plots aren't showing up. So the next thing we want to see is another kind of plot, which is called a histogram. Now, a histogram is a great way to see the distribution. Distribution is a fancy word for spread of data. So you imagine this, most of our odometer readings are between, let's say this is 20-odd thousand up to 100,000. So the reason you can see this kind of curve shape here is because this is where the average about odometer readings fall into. And that these 2 values out here might be considered outliers because they're not within this big clump of values. So that's an easy way to run a histogram on your numerical columns. Let's have a look at the price column. We want to see what different prices of cars we have. Dot plot. Now why is that? Why do you think that came up? Do you remember no numeric data to plot? Why is that? Let's have a look at the data type, price.dtype. We did .dtypes at the start in one of the other videos. .dtype is just on a single column. So dtype O for object. So it's non-numeric. So our error is non-numeric data to plot. What can we do here? Now we could plot around for a bit and try to get this to work, but let's have a look at how we might research a problem like this. But we might type in how to convert a Pandas column price to integer. Price column object to int in Pandas. Now this is a step you might take if you run into some kind of error. We could always play around with this price column to try to fix it. But I want to emphasize what an actual workflow might look like when you're looking up something. So we've Googled how to convert a Pandas column price to integer because that's what we want to do. We might click on this, Stack Overflow. I have a column called amount withholds values that look like this. Now what you want to do is when you get to somewhere like Stack Overflow, you want to see if this description of this question matches our problem. So they have a column called amount which holds values that look like this. That's similar to us, but ours is called price. When I do dataframe.dtypes, it returns this column as an object. So does ours. How do I convert this to type int? Yes, that's what we want to do. Let's have a look at some of these answers. Okay, this is using regex. What you'll do with these answers is kind of look through them and see which one stands out to you the most. This green tick means that the question asker has marked this as the right answer to help them solve their problem. But sometimes there's other ones, like maybe this one here. I want to use one without regex because regex kind of confuses me. So this has also got 5 upvotes. One of them is mine, previously in doing research for this video here. So what you might do is copy this. And so this, you can see they've started off with amount, which is like our price column, and it's come out like this, which is what we want to do. We want to convert our price column. Let's have a look. Car sales. We want to convert our price columns to something like what our odometer column looks like. We've copied this piece of code from Stack Overflow. We're going to type it in here, but we're going to use it as reference, right? Because we want to get practice writing our own code. So we're going to compare it to what ours is. Let's zoom out one little bit so we can see 2 cells at once. Excellent. So this is saying data frame with a column amount equals data frame amount dot string dot replace. Some interesting combination of code there with nothing as type int. Now that's a fair bit in one go. But let's try replace the parts that we do know to our own. So data frame, our data frame is actually called car sales. So we're going to type in car sales. Our amount column is actually called price. So we'll type in price. And we're going to reassign it to car sales or price. Because what this is saying is, hey, grab the price column and set it equal to this, another car sales.price column. But let's put some adjustments. So this means access the string and replace. Now this little funky combination of slashes, dollar signs, comma, and dots is saying, hey, find these symbols within the price column and replace it after the comma, replace it with nothing. And then change the type with as type to integer. So let's go through that one more time. Car sales price column, we want to readjust it to equaling the car sales price column, so keep the values the same, but access the string and replace the dollar sign, commas, and dots, so dollar sign, commas, and dots with nothing, so this is an empty string, and then change it from a string, so dot as type integer. Whew. Now that was a mouthful, but remember, if in doubt, run the code, shift and enter. Now let's see what our car sales data frame looks like. Beautiful. We've changed the price column to look more like the odometer column. Oh, what's happened here? Ah, the price column has included the cents. So maybe that's an exercise of how to fix that, to not include the cents, because we only want it in thousands, and this has increased it. So now the white Nissan is now $970,000. But let's see if we can plot it now. Price dot plot. Beautiful. So the plot is incorrect because the numbers are just way too high, but at least we can plot it now. So the next thing we'd look at in terms of manipulating data is looking at this line of code and going, how can we readjust that? So then maybe that's a little exercise you could try. Try to readjust this line of code to not include those last two zeros on the end. And now we've seen a few different ways of viewing and selecting data, some of the major ones with Pandas. We'll now look at a few more ways that we can manipulate data. So take a little break if you need, go back over the code we've gone through, and I'll see you in the next video.